Flow control part 2. What we're going to do now is turn our attention to another aspect of flow control called repetition. And basically what repetition does is help us do things over and over and over again without having to write the code over and over and over again. Now, basically what I'm talking about is looping. Looping gives us three different formats, or I should say rather, there are three different forms of loops in Java. There's the while loop, the do while loop, and the for loop, okay? And all of these have some different features that I really need for you to pay attention to, because one of the questions is, well, listen, why do there have to be so many loop constructs? Why 3 loop constructs? Why not just one that lets me do something over and over and over again? Well, the truth is they all work a little differently. And one of the things that I want you to pick up on is, when would I use a while loop versus a do while loop or versus a for loop, okay? Then what we're going to do is talk about how you can use two special keywords, the break keyword and the continue keyword, to help control repetition. The first loop that we're going to take a look at is called the while loop. Now, I've gone ahead and flowcharted the logic out, okay, how this loop is going to work. As a matter of fact, I've flowcharted all of these out because this is where you're going to see the difference in how the loops function. So let's take a look at what's going on here. Remember, loops help you control program execution. So program execution is chucking along here. It's doing its thing, we're doing our thing, moving and moving and moving, okay? Then what happens is we come to a statement over here. Now this statement can be a variety of things. I mean, these are just Java statements. What's going to happen is at some point you're going to hit a decision. Some kind of condition needs to be evaluated. Now what this condition is going to really determine is whether or not you're going to continue. So what's going to happen is, if this evaluates to true, you will execute a statement, then come back and then ask the question, is this true? If it is, you will execute this statement, come back, and ask again. If it's true, you execute and come back, and that's what's going to happen. Now, once this continuation condition evaluates to false, then what happens is you are now out of the loop, and then the remainder of program execution continues, and you just go about your way in your program flow. So I've gone ahead and prepared an example of using the while loop. Now, what we're going to do first is take a look at this chart here where I've got it flowed out using a flow chart. So this would represent our first statement, our first action. Now, this first statement here is merely declaring a variable of type int called I, who has been assigned the value of 0. That's all it's doing, okay? So this is just a statement. It's not really part of the loop. Remember, program execution just, executes, executes, executes. We have a statement, okay? Then what happens is, okay, so this statement is executed. Then what happens is a continuation condition is asked. It's evaluated, okay? And here we're saying, hey, is the value of I less than 100? Well, it is, right? Because it's the immediate preceding, or the previous, I should say, statement initialized I to 0. So of course I is less than 100. So right now, because its value is 0 right now, okay? So this is true. This is the true condition. So then what we're going to do is print high. That's the first thing we're going to do. And the second thing we're going to do is increment I plus plus. Remember, that is the increment operator. So this will become 1. Okay, then we go out and we ask the question again. Well, now I is 1, right? Is that less than 100? You bet. So print high to the screen and increment it. Okay, so we ask again. Okay, so what happens is we go to like now I is 99. Is it less than 100? Yes. So go ahead and print it. Now I is 100. Is I less than 100? It is not less than 100. It's not greater than 100. It is 100, right? So all of a sudden, when we hit this demarker here, the 100, we are now false, and we break out of the loop, and we just continue about our business. In this case, we go ahead and print done. So that's the idea here. So let's go ahead and open up a Notepad text editor and put this thing to work. I'm going to use the run dialog, so start run, to open up Notepad. And I'm going to go ahead and create a public class. So public class, we'll call this while demo. So capital H, while demo. And I open my curly brace, close my curly brace. And I put in the famous signature that you totally have to memorize, public static void main, capital S string args. Now I kind of changed that up. That's legal. This whole string arg things will come together for us when we go over working with arrays. So for right now, I just need you to take that on faith for a little bit. And let me open the curly brace, come down here, and close it and give myself a little bit of room to work. Now I'm going to go ahead and save this file as capital W while demo.java. Notice that I save it in double quotes, so it doesn't save it. If I do not save this file in the double quotes, it will save it as while demo.java.text. Okay, and then that won't work at all. So we want to put it in quotes so it's taken as literal. Okay, so I go ahead and save that. All right, now what I'm going to do is I'm going to go ahead and put my first statement in there. Int I equals 0. And I go ahead and hit enter. Okay, int I equals 0. First statement. Now here is the syntax for the loop. I say while. I lowercase w. I open a open parenthesis, and inside of here I put in my continuation condition. Now this continuation condition must evaluate to a Boolean, either true or false. So here I'm going to use I is less than 100. Remember that the less than symbol is an comparison operator. Okay, it's used to compare values. Then I open up a curly brace and I close the curly brace. So the statements of the while loop are contained within an open and a closing curly brace. So I'm going to do system.out.println, and I'll say, how about I plus, the addition operator here is a string concatenator, and more on that in a little bit. So I'm going to concatenate a parenthesis with high, close that. Then what I'm going to do is I'm going to increment I. Listen, I need some way of breaking out of this loop. Otherwise, I'm going to either never execute it or be in it forever. So as long as I have a counting mechanism, I know at some point I'm going to break out of the loop. Then we'll put in our last statement of system.out.println, and I'll say done, or if I spell done right. All right, so I'm going to save that, bring up good old command prompt. I'm going to compile, so Java C, capital W while demo.java. Give that a second here. And we should come back with just a command prompt, assuming that there isn't any problems. Good. Remember, no news is good news. I do a Java while demo, and we execute it. And you can see, let me kind of scroll up in here, we start with I of 0, right? Because notice how the increment hasn't happened. I set it equal to 0. Is 0 less than 100? You bet it is. So print out the value of I, which is 0, then the parenthesis and the word high. Good. Now increment. So now I is 1. Is 1 less than 0? You bet. So go ahead and print out 1, etc. So now I'm going to scroll down in here, and now we're going to say is I is 98. So is 98 less than 0? You bet. So print 98, parenthesis high, increment 99. Is 99 less than 100? You bet. So print it out. Now it's, and then increment. Now it's 100. Is 100 less than 100? No, it is not less than 100. It equals 100. So therefore, this now evaluates to false. We break out of the loop and we print the final statement of done. All right, the next loop that I want to go over is the do while loop. Now, although the do while loop sounds kind of like the while loop, it actually works a little bit differently than the regular while loop. Let's take a look at the flow. Okay, so program execution is happening. Then what happens is a statement is executed. A statement is executed. Then we ask the question, should we continue? If we continue, if the continuation condition evaluates to true, we execute the statement. Then we're asked again, true or false, does the continuation condition evaluate to true? Yeah, go ahead. So we loop, okay, we loop through here until this becomes false, in which case we break out of it. I don't know if you've picked up on this already, but the major difference between the while loop and the do while loop is the do while loop, this first statement executes at least one time. If I go back to the while loop, the continuation condition is asked before the statements that you want to loop, okay? So the continuation condition is asked before the statements that you want to loop. Whereas in the do while loop, the statement of the loop, what you want to happen potentially multiple times, happens at least once. Then you are asked if you want to repeat that again until it's false. All right, so let's go back into Notepad and let's create a new class. So public class, and I'll call this capital do while loop demo. And open the curly brace, close it, and then public static void main string args, and then open it up, close that, and we're all good. Let me go ahead and save this file, and we'll save this in quotes, of course. Let me cancel this. I'm gonna right click on there and do a quick copy, get the name, do a save as, bring you up, and do a quote, control V to paste, dot Java, end quote, and save it. Now check out the syntax. Now the syntax, believe it or not, is a little kind of weird. There's one little weird thing to this, okay? So I'm going to do my first statement of int I equals 0, okay? This is going to be used to help me count. I need some mechanism for breaking out of the loop. Now, here what I do is I say do, the do keyword. Now I open up my curly brace, okay, and I create my code block there. Notice how I'm not, at this point, doing any kind of continuation condition evaluating. So what I'm going to do here is I'm going to say system.out.println, and we'll just print I. Then I'm going to increment I. Okay, so here's where it gets a little weird. Do this while I is less than 10. Now, this you cannot budge on. The while is going to come right after that curly brace, your continuation condition, and yes, you are right, you are not seeing anything. You are absolutely seeing a semicolon. So notice the semicolon. Yeah, that is part of the deal there. It won't compile if you don't have that, so you definitely need that. So system.out.println of done. All right, I'm going to save that. Let's bring up a command prompt. So type cmd and hit enter. All right, let's compile. So java c do while loop demo.java and compile that up. get our command prompt back, and now let's do a Java do while loop demo, and let's see what's going on. All right, now int I equals 0. Set that to 0. Do print out I. That's why I'm seeing 0 there. Hey, do that first. Now increment it. Now, is I less than 1? You bet it is. It's 1. So go ahead and print out I. So we have 1. Increment it. Now it's 2. Okay, 2 is less than 10. Print it out. Now I is 8. Is I less is if I is 8 here and we increment it, then it's 9. Is 9 less than 10? You bet. Now we increment, so we have 10. Is 10 less than 10? No, 10 is not less than 10. It is equal to 10. So we're done with the loop, break out, and go ahead and do the last statement there, which is done. Okay, so that's the do while loop in action. The last loop we're going to talk about is the for loop. And the for loop is a little bit more complex, but extremely, extremely powerful. Here's what it kind of looks like in flowchart form. The first thing you're going to do is have an initial action, what we would typically call the initializer. Something happens to initialize the loop. Then you have a continuation condition evaluated. If it's true, perform the loop and then perform the increment or the iteration. Then ask again. If it's true, perform the loop statement, increment, ask again. If it's true, perform the loop statement, increment, ask again. If it's false, we're out of there. Okay? So the thing that we have to understand is the for loop has essentially 3 components. The first component of a for loop is the initialization or the initial action that happens. The second part is basically the evaluation. Okay, the evaluation. This is the second part, the continuation condition. We have the body of the loop, do whatever has to happen, and the third construct of the loop is the iteration or the incrementer. All right, I'm going to start off with a fairly straightforward loop, using a for loop to count to 10. So let's create a public class. We'll call this for loop demo 1 because we're going to have a couple of them. And I go ahead and create my public static void main string args here. Open the curly brace, close the curly brace. If I could kind of set these files up and basically have them templated, and I'm going to be going there eventually. The reason why I type that out every single time, because I feel that if it's important for me to type that out every time, then I'm really trying to get at an important concept here of how to declare an essential class, how to create the main method. That is a critical thing. Let me just tell you something. If you're taking the Java exam, there are questions on the Java exam that are like give me questions, and some of those questions, a handful of them, are just simply creating the main method correctly. So it's really critical that you grasp onto that. And for those of you who are new to Java, I know that that can be a little bit confusing at first, so I'm repeating it. All right, so I'm going to say that is for loop demo 1 dot Java. All right. And here's the basic syntax, for, okay? Then I have the initializer. So I'm going to initialize int I equals 0. Now, here in a few minutes, I'm going to do some stuff there that's going to potentially freak you out. Because I'm thinking a good amount of you may have seen this. I have my condition, my continuation condition, and I have my incrementer. Now I'm going to have the body of the loop. So system.out.println of, we'll just simply print I, and then I'm going to print done. So system.out.println done. All right, save that up. Let me bring up a command prompt, cmd. Next, I'm going to compile using the Java compiler, so for loop demo1.java. Compile that off, and then we're going to run it. So Java for loop demo1. All right, so let's see what's happening here. The first thing I want you to do is, or the first thing that's going to happen, I should say, is run the initial action, the initializer, which sets an integer whose name is I equal to 0. Next, what we're going to do is we're going to say, is I less than 10? It is. So execute the statement. So that's why you see 0 there. Then increment I. Okay, so we'll do that next. So now I is 1. So I is 1. Is it less than 10? You bet. So go ahead and print it. Now it's 2. Okay, I is 8. Is 8 less than 10? Yes, it is. So print it, increment it. Now it's 9. Is 9 less than 10? Yes, it is. So print it, increment it. Now it's 10. Is 10 less than 10? No, it's not. So we're done. We're out of there. So that is the essential construct of the for loop. It's important that you see that this happens first. This happens first. Then this happens next. Then whether or not that's true or false determines whether or not this will happen. Then we have an incrementer. All right, so that is for loop demo 1. But what I want to show you is you could actually start doing some cool things here. I'm going to change this to a 2, and watch this. I'm going to declare int I equals 0, comma, because I can declare multiple variables there of different types of the same type, and x equal, let's say, 10. Okay? And then what I'm going to do is I'm going to do a, I think I'll put that back on the same line here. So I'm going to append in there a comma, and then I'm going to go ahead and say x. And what I'm going to do here is I'm going to say comma x minus minus or decrement x. Okay, so let's save that off. And let me clear this. Let's do the old compiler for loop demo2.java. You know what? I didn't save the file as for loop demo2. So save as, let's put that in quotes, home, quote that, 2. All right, so I saved that. Now let's do that again. So Java C for loop demo2.java. All right, compile that off. Now let's run it. Java for loop demo2. Now look at this. This is pretty neat. I is less than 0. I'm sorry. I equals 0. X equals 10. Now, is I less than 10? It is. It's 0. So go ahead and print the value of I and the value of X. So 0 and 10. Okay, now increment I, so I is now 1, and decrement 10, so decrement X, so I is now, or X is now 9, okay? So what's happening here is, what I'm demonstrating here is you could declare in this initializing statement section, or the initial action statement, you could comma separate several things to do here, okay? You can also have several things to do at the end of it in the decrement, I shouldn't say decrement, but more of the increment. However, if you're incrementing or decrementing here, the iteration section, you can have several comma separated options. The only place where you're limited is you can only basically evaluate one condition. So you couldn't have I less than 10, X greater than 0. You can't do that. Only one type, okay? So Let me go ahead and show you even some more things that you can do with this amazingly flexible loop. Now what I'm going to do is rewrite essentially this same loop a little bit differently, just so I could show you how flexible this syntax is. So let's change this to demo 3, and this time I'm going to remember to name it correctly. So put the quote around there. I don't trust Notepad fully yet, so change this to a 3 and hit end on the keyboard and save that. All right, so demo 3, demo 3. Now watch this. Put a little room here. I'm going to declare int I equals 0, comma, x equals 10. This is a perfectly legal statement. I'm declaring two variables, I and x, of type integer with their associated values. Now watch this. I'm going to get rid of this statement entirely and leave it blank. Okay? Watch this here. Within the body of the loop, I'm going to increment I and decrement x. And I'm going to essentially get rid of that. Save it. Clear. Let me move this over here just a bit. Compile Java C for loop demo 3.java. Okay, because not all parts are mandatory. As a matter of fact, none of those parts are mandatory. Now we'll do a Java for loop demo 3, and we get the same result. Okay, check this out. One of the worst things that you can do is have an infinite loop. That's an infinite loop is in your code where you've made a mistake and you basically are repeating the loop ad infinitum, and basically it causes the computer to crash. Now, there are times where you actually want an infinite loop. You could create an infinite loop by just getting rid of that and just have basically this kind of a thing in there and have absolutely no conditions. It will just, that right there is an infinite loop. It's a little scary. The last thing that I want to show you is some other things that you could put inside of this little area here. So watch this. Keep the same example a little bit. I'm going to do system.out.println. I'll say this happens first. Okay. So long as I is less than 10, and I'll say system.out.println, this happens every increment, or every, I'll say, iteration of the loop. Okay, so follow what I'm doing in here. Okay, just so you can see that you can put a lot of different things in there. You're not stuck with just one thing. So let's save this as demo 4. Save the file as demo 4. So quote 4, quote, save. Let's compile it. So Java C for loop demo 4.java. Compile that off. Now I'll compile that, so I'll do a Java C for loop demo 4.java, and we'll run it Java for loop demo 4. Now look at this. This happens first. So as far as the loop is concerned, this is the first thing that happens. That's why you see this happens first. Then the whole, print determining the continuation condition, then we print out 0 and 10, then we do the increment and the decrement, and then this happens every iteration is coming from over here. That's why you'll see this happens first only once, because it only happens the first time. then this happens every iteration, and then finally we're done. So extremely flexible as far as what you can do with those loops. What I want to do now is wrap up with a discussion on using the break and continue keywords in your loops. You see, those keywords are implemented in your loops to either stop the entire loop, which would be the break, or go ahead and keep the current iteration using continue. Basically, if you're going to be utilizing the break and or the continue keywords in your loop, essentially what will most likely happen is you'll go ahead and run an if test within some loop. And if that if condition is true, or basically false, depending on how you want to do it, and you want to exit that loop immediately, you could take advantage of, in some way, shape, or form, the break and continue keywords. Basically, what is the difference between those is whether or not you continue with a new iteration or jump to the first statement below the loop and continue from there. So let's take a look at continue. Now, this is just a pretty simple kind of a way of seeing what's happening. And this is essentially a for loop, but I go ahead and have continue in there. Remember, the continue statement basically causes only the current iteration of an innermost loop to cease and the next iteration of the same loop to start if some condition is true. Now, if you're utilizing it in a for loop, keep in mind the effects on loop iteration. So let's just take a look at how that operates in a simple example here. So I've already compiled it, so let's run it. Continue demo. And you can see it basically has the effect of saying, okay, just go to the next iteration. Now, what's a little bit more powerful and interesting is the break. So let me go ahead and say notepad. Let's go ahead and go notepad and all right, notepad, and I'm going to open up an example using the break. So open that up, and let me just do a all files in here, and here's the break. Okay, now watch this. This is scary. Look at this. I create a Boolean B called true, and I'm creating an infinite loop here. I literally put the word true in there, which means this while loop will run till my computer crashes. I also put another nested infinite condition in there. I'm doing a test, which is also true. This will always evaluate to true because B is true. But look at this. Notice how I'm using the break keyword there, which is going to cause this statement in program execution to stop in this innermost looping and basically go to the next line. So let's take a look at how that works. I've already compiled it, so Java break demo. You can see I have no fear of running into any kind of infinite issues here because I've gone ahead and I've used the break statement appropriately. In Flow Control Part 2, we took a look at repetition. And primarily we have one major mechanism used for repetition, and that's looping. We took a look at the while loop. The while loop is pretty much good when you don't know how many times this loop is going to execute. You have no idea, so you basically set up a counting mechanism in some condition. Now, the condition is evaluated before the body of the loop using the while loop. We took a look at the do while loop. This is essentially the same as the while loop in that you don't know how many times it's going to execute. That's why you set up a counting mechanism. But with the do while loop, the body of the loop, the main statement, happens at least once. Now, the for loop is different from any of those while loops because you know how many times that is going to execute because you're setting up the incrementer as well as how many times to iterate through that. You can take advantage of the break and the continue keywords to help control repetition. I hope you have found this informative, and I'd like to thank you for viewing.